Welcome to our first unit in psychological statistics. In this unit, we're going to be starting out slow to offer a review of information that you already know and then to give you a chance to get to know my teaching style. So consider this first unit to be our warm-up unit. It's actually going to be really important that you master the concepts in this unit so that you're ready to put them to use in the next. Today I'm going to cover types of variables. That is, I'll be covering the different qualities that numbers can take, as well as talk through what those properties mean. The most basic thing a number can do is name or describe something. These types of variables are called nominal. When numbers are operating on the nominal scale of measurement, they don't contain any information about quantity. Instead, they are simply about quality. If I poll a group of people, say our class, and I ask them to name which ice cream flavor they prefer, chocolate, vanilla, or strawberry, I could assign numbers to each choice. I could say chocolate gets a 1, vanilla gets a 2, and strawberry gets a 3. But these numbers don't mean anything about the quantity of ice cream. It wouldn't make sense for me to take the average of these numbers and find out that our class average is a 1.67. 1.67 doesn't even exist as an option for a flavor. And it wouldn't tell me anything I need to know about our class's ice cream preferences. Instead, I would actually just need to find the most frequent number. That would tell me the most people in our class prefer this flavor. Another example of the nominal scale of measurement is jersey numbers. These don't tell us how fast a player runs, how skilled they are, or anything about the quantity. Instead, it simply names the player. The second scale of measurement is ordinal. At this level, numbers start to contain minimal information about order, even though they don't contain precise information about quantity. So an example of this scale of measurement is placing at a race. We know that someone who came in second ran slower than the person who came in first, but better than the person who came in third. We don't know the precise difference in their time, just this relative difference. Another example of this rating might be hotel ratings. You can reasonably expect a 4-star hotel to be better than a 3-star hotel, but you might not know the exact improvement in quality that you're going to get. The next scale of measurement is called interval. On this level, numbers have equal intervals between them. The difference between 2 and 3 is the same as the difference between 3 and 4. In this way, numbers actually represent precise quantities. On this scale of measurement, 0 is arbitrary. That is, 0 does not mean nothing. 0 is just like any other number. It's 1 unit below 1, and it's 1 unit above -1. Most personality traits and individual differences we measure in psychology are on this scale or level of measurement. For example, if I ask you to agree with the statement, I have high self-esteem, on a scale of 1 to 5, where 1 is not at all and 5 is very much, there's actually no number that represents no self-esteem. Instead, we talk about self-esteem as relatively high or relatively low. What if I used a different scale, say from 0 to 4, to measure your self-esteem? 0 means not at all, 4 means a lot. You might indicate 0 here, but even so, you're not telling me you have no self-esteem. You're just indicating that you strongly disagree with this statement. Lay people often talk about personality in a way that makes it sound like personality has an absolute 0. They'll say things like, that person has no personality. But that's not really what they mean. They don't mean that that person's personality doesn't exist. They actually just mean that the person is really boring or has really weak personality traits. The next scale of measurement is the one that allows for this kind of statement. It's called the ratio level. On this level, numbers have equal intervals between them. So the difference between 16 and 17 is the same as the difference between 4 and 5. The intervals are the same. But in this case, 0 is absolute. What that means is that 0 means nothing. If I ask you, how many dollars do you have in your checking account, and you say 0, that means you have nothing. You have no money. One mistake people often make between the interval and ratio scales of measurement is temperature. Most formats of temperature, including Celsius and degrees Fahrenheit, are actually on the interval scale of measurement. That is, 0 doesn't mean no temperature. And instead, it means really, really cold. There is a measure of temperature where 0 is absolute. That's called kelvins. 0 degrees Kelvin means no temperature. I don't know about you, but I don't even know how to process what that means, what no temperature is, but it exists. And Kelvin is a variable on the ratio scale of measurement. The key about variables like this that are on the ratio scale of measurement is that you can make ratio statements with them. That is above and beyond saying that the intervals between numbers mean a constant quantity. You can also say things like $10 is twice as much as $5, or 1 mile is half the distance as 2 miles. That's it for type of numbers. The specific features of numbers will make a difference when we get around to actually working on statistical tests. Some tests are more suitable for numbers on one scale of measurement than the other, for instance.